Good afternoon to all of you. I am PLN Raju. I will be talking today on satellite based augmentation systems. Ashutosh Bharadwaj, he has started the program. He has given the introduction to global navigation satellite systems, talking about how to get the position, what are the different constellations available, like GPS, GLONASS, GLONASS and Galileo, etc. And then you are also told through GPS, through GLONASS and other systems, you get position. So that X, Y and Z positions. In that, there are various methods to get a position. One is if you take it in a standalone, so and then that means you take GPS to the ground and then you take measurements, so you get your position. So that is called absolute positioning. Another is it was also told about a differential global positioning system, that is DGPS. Once we do this, how this positional accuracy improves from 15-20 meters to 1 meter, centimeter, millimeter accuracy. And then you also use different type of instruments, like one is common instrument, what normal GPS what we use, which comes very cheap, 10,000, 15,000, 5,000, etc. Another is survey grade equipment, etc., where it is we get a higher position, where you have more than one channel, etc. So there you have a L1, L2 frequencies, and then you do different type of survey techniques. You are also going to improve your positional accuracy. So today what I am going to talk is, it is slightly different than the what you do with the different survey techniques, what has been explained earlier. In this, what we will do is we will augment the systems. So that means whatever position you are getting, and then if you augment that, other than that different survey techniques, what has been explained, so you are going to improve your positional accuracy. If it is coming around 15-20 meters, with this satellite based augmentation systems, we can also improve the positional accuracy. So that accuracy can go up to a meter level, or in some cases, some of the companies claim that they can go into centimeter level. So there are different systems are there. So they are at the global level, they are at the regional level, they are at the local level. Once we use these different techniques, so then you are able to increase your accuracy. So compared to that standalone position or absolute positioning to DGPS, differential global positioning systems, standalone is very cheap. You have GPS equipment. You once one instrument is enough, then you use that. So then you are going to get a certain type of accuracy. And what Ashutosh has mentioned is something like you go DGPS, that is highest accuracy, but at the same time the cost is very high. So it can goes to maybe 10-20 lakhs to 1 crore or more than that. But what I am telling today now is it is in between single instrument, and then in between the DGPS we have satellite SBOS systems, which are slightly higher cost but not very high cost. There is affordable cost. Suppose even you spend 50,000 or 1 lakh, so you are able to get good SBOS systems which can give accuracy up to 1 meter level. So there are some viewpoint I wanted to put in front of you, like basic understanding of like what is augmentation systems. It is something like you have the system, like GPS is there. Suppose if you improve that signal, then the accuracy will going to improve. Something like you basically what is done is, it is done in a relative positioning mode. Suppose in a DGPS if you talk, it is done in a relative positioning mode, so that local area you will get a higher accuracy. In this case, what is happening is it is done similar like that, but it is done for a broader area. So for whole country, I am talking about for whole country, for a whole region, this type of augmentation system can be developed. So there are different augmentation systems. I will come into the detail of that. In India, we have Gagan. In USA, they have a WAS. This is a vast system. These systems are serving for the whole country. So that means the system network which is established by the country, so that network, whatever is established, from that we use those values, those readings, and then using those values readings, you are going to improve your accuracy at the position where you are standing. So it is something like a regional system, or something like a global system if you are doing for the whole world. Importance of position is always required. You talk about any application. Suppose you talk about a cadastral application, even each inch of a land in particular city, if it goes this side or that side, people will not agree for that. So that means the positional accuracy is very important in cities. And then if you go to that strategic applications, if you are having a targeting some position to hit the target, so if your positional accuracy is not good, so it may not hit the place where you wanted to hit. So that's why positional accuracy is always important. So for all these purposes, so GNSS is used. GNSS means GPS, GLONASS, Galileo, etc. As I mentioned, absolute accuracy is something like you use one instrument and try to find your position. So it is, you are connected with only the satellite systems. You are not connected with the DGPS. You are not connected with your SBOS system. It is standalone. You press the button, you get your position. Relative positioning is DGPS. SBOS system is also relative positioning system. So using a relative positioning, you can improve your accuracy. If it is 20-30 meters, you can bring it to 1 meter or centimeter accuracy. Accuracy versus precision. Accuracy is whatever is what is the actual to the what you achieve. So that is accuracy. Suppose on the ground, if the positional accuracy is such and such things, latitude, longitude, and these things, and instead of that you are getting something else, so that difference is called accuracy. Suppose if you have Survey of India, benchmarks are there, trigonometric benchmarks, so there the accuracy is very high. So, and then you go and you will take your GPS positioning there, see the difference, then you will find out maybe it is 20 meters, 30 meters, that is the called accuracy. Precision is the capability of the instrument. The instrument which can be used, how precise you can get it. How precise the, suppose whatever is the display system is there, if it is showing in 1 meter or it in decimeters, so the precision is, it is within the range of 1 meter. Suppose if it is 10 centimeters, so the precision is 0.1 meter. So that way it is a instrument capability. Accuracy is from the actual to that what you measure, the difference is that accuracy. And then you say global positioning system to regional systems. If you have this satellite constellation like GPS, and then you use for the whole world, so those are all called global systems. Suppose you use the same type of satellites, but you limit to the particular area, so then those are all called regional systems. So China have launched their own regional systems. India also has launched 4 such satellites regional systems. So they are all called IRNSS, Indian Regional Navigation Satellite System. So this system is developed to cover the area of the India and surroundings up to 1500 kilometers. So these IRNSS, we also arrange a lecture. I think Ashutosh has also sent that timetable to all of you. So we have a special lecture on IRNSS. So that will be again discussed further by experts in that regional system, like our own IRNSS. You have a special topic on that. So DGPS is Global Navigation Satellite System. So I need not go detail in that because it has been covered already. So government systems versus private systems. See, these are all GPS is launched by USA Defense Department, and then Galileo is going to be launched by European these things, and then you have a GLONASS also launched by Russian system. So these are all government systems. In addition to the government, private people are also coming forward to provide the positional accuracy. So now, as of now, may not be satellite systems are not there, but they are there providing the service to improve the accuracy using these government systems. Why the government is giving importance to this? So, as I mentioned earlier, positional information is very important for many applications. I mentioned about urban application. I mentioned about strategic applications. So, same thing can be also used for agriculture purposes. Precision farming. So, it is very advanced technique. Once you know the position, once you know that in the position, what is the capability of that land, fertility condition of that land, how to add a type of particular fertilizer so that every land is covered uniformly, land potential can be improved for a better crop production. So that's why precision farming is one of the things where this is very important. That's why all the governments are coming forward to give importance to these GNSS systems. Accuracy versus different applications. See, this depending upon the accuracy, different applications have been developed. Suppose if you go to the ocean and try to catch a fish, if it is 1 meter or 10 meters, so it doesn't make difference. But if you go for the cadastral applications, so even 1 meter this side or that side is also make a change. If you talk about plate tectonics, when the Everest this one plate is moving upwards, so there your accuracy requirements is in millimeters. So every year it is coming like a 4 centimeter something upliftment takes place. So there you require accuracy of in millimeter, so that you are able to get the what is how it is going to lift. So the particular application have a particular type of accuracy requirements. As I mentioned, the satellite-based augmentation systems, SBOS. So these are all wide area or regional augmentation systems. What the basic principle here is, they are also like a similar GPS instruments or GLONASS instruments, or a combination of both. Both together, combined together, also you can make a GPS equipment, having a GPS plus GLONASS together. But in case of SBOS, the additional thing required is these systems has the capability to receive the signal from broadcasting messages. We say there is also called geostationary satellites. The GEO orbit, that is geostationary satellite are there, geostationary Earth orbit system, GEO they are called. So these satellites are also used to broadcast the signal of the errors for the local area, so that once this broadcasted, so that signals are used to improve the accuracy. I'll tell how it is done, but these wide area systems are using this additional satellite broadcast messages so that they can increase the positional accuracy. And then you have a multiple ground stations located at accurately surveyed points. The ground stations take measurements of one or more of the GNS satellites. The satellite signals or other environmental factors which may impact the signal received by the user. So that means this ground, in case of SBOS, what we are doing is we are establishing a network of these ground stations. We suppose in India we have around 8 or 10 stations. They spread all across India, and then those points are used further to improve the accuracy. So this system is called a GAGAN, Geo-Aided Augmentation Satellite System. So those I am further discussing on that, but there is also a special lecture on GAGAN So from the experts who are working on the Gagan project from Indian Space Research Organization, so they are going to deliver a talk on that. So you'll get much details on that. What is happening in this satellite-based augmented system is information messages are created and sent to one or more satellites to broadcast. What is happening is these are 8 or 10 stations on the ground, and then what they are doing, they are observing and getting the position from the satellites or GPSs or GLONASS satellites, and then they are calculating the positions at the place where they are located. And then at the same time, so we are also doing a field survey for these points in advance, like collecting GCPs, ground control points. So at these places where these GPS receivers are placed, control GPS points, so those places you are again measuring from the ground, like survey grade total stations or survey equipment, measure precisely and get the coordinates, and then those coordinates are fed into the your GPS stations, so GPS wherever located. So those things again they calculate the error, and then those errors basically again communicated to the ground antenna, and then from that ground antenna again link up to the geostationary satellite. In our case, INSAT satellites. In USA, they have their own network of INSAT satellites. So they uplink to the INSAT satellite system, which are there at 36,000 kilometers. So once they are uplinked, and then as a general user, when you go there to the ground, you press the button, and then you get your own position. What is happening is the same GPS receiver is also having the equipment. This equipment is capable to get messages from these geostationary satellites, so that it will see that the satellite, whatever message it is coming, giving the positional information, and then the satellite errors, and then it will calculate the position. That means whatever it is giving the position without this signal, and once you take the signal of this and then combine together, you are automatically improving the accuracy. So this another thing is SBOS is sometimes synonymous with wide area differential global positioning system, or we can also say wide area DGPS. To summarize what I said, this is satellite-based augmentation systems. You have a GPS satellites. This cyan color, what is shown here. So these are the GPS satellites, and then you have that ground fixed stations. So these are the antennas, whatever you place. These are the basically GPS stations, ground stations. So these GPS ground stations, one is here, one is here. So like that, there will be a network of points, and they continuously collect the measurements at these points, and then again they communicate to the master control center. So that is based on a ground-based network. Either that ground-based, through the ground-based network, so it is connected to the master control center. So that master control center will uplink these messages, this information of the ground stations to the your geostationary satellite. So this, once it is connected to geostationary satellite, which is there 36,000 kilometers, whereas your GPS is located at 20,200 kilometer range. So once it is gone there, and then it is again rebroadcasting to the ground whatever messages it has received from all these ground stations, whichever is wherever you go with your instrument, SBOS systems, if it is located to near to those ground stations, so it will use this information to calculate the position of that point. What is happening is, when we talk about GPS, it is basically giving the time difference for the at what time the satellite has sent the signal, what time you received it. So then it will calculate the range and give the positional information. So and then once it is received, it also goes through the atmosphere, and then it also goes through the ionospheric layer. So these layers delay the signal. Once they delay the signal, your accuracy is reduced. Instead of giving a high accurate information, you will get information around 20 sorry 20-30 meter. That is where you get your accuracy. Once that is coming, basically it is basically that error is also coming along with that. This ionospheric error, atmospheric errors. Once you know these errors, and then you also know the position of your own ground station. So that means you detect the error, automatically the error is detected. This much is the suppose 20 meter, 30 meter is coming. It is coming because of that atmospheric and ionospheric problems. So that you correct it for the ground station, and that time error also is eliminated in that. And these atmospheric and ionospheric errors are basically localized. It is also there everywhere. How much is the ionospheric contributing? It is localized. Suppose if you remove for one ground station, as a surrounding ground station also will have the similar effect. And then once you are removing from the base ground control station, you get that error difference corrected. Same thing you can also distribute to the instrument what you are carrying. So once you carry that, so then that will be removed. So that way your accuracy is improved from 20 meters to 1 meter. So like aeroplanes, if they have that GPS, so these aeroplane also will be also get corrected for the accurate positional value. Similarly, wherever is on the ground around those points, you will also get improved accuracy for those points. As I mentioned, this satellite based augmentation systems, so there are various satellite based augmentation systems, regional and global, etc. For India, we have a this is IRNSS. See, this is a regional navigation system, but it is not a SBOS system. So it is, you understand that I mentioned here, but it is not exactly that SBOS system. It is a regional global navigation satellite system, Indian regional this thing. Whereas VAS is a SBOS system, wide area access augmentation system. It is for the American region, whole American continent. It will cover this VAS. So there are around 50-60 points are there. So those points means collecting station, ground stations where GPS is located. So those points are used for improving the accuracy. As I mentioned earlier, Gagan is Indian SBOS system, GPS aided geo-augmentation navigation it is. Similarly, you have a IGNOS, it is for European Geostationary Navigation Overlay Service. All these, what I mentioned, VAS, Gagan, IGNOS, they all use a GPS as a signal. So from that GPS signal, so they correct the positional accuracy for the ground point. Similarly, for Japan, multifunctional satellite augmentation system, MSEAS is there, and then they also have a QZSS, QZ Zenith satellite systems. So it is they augment this thing, as well as they have a special satellites are launched for this to further improve the accuracy for that reason. And then system of differential correction and monitoring. So this is also another system, also comes as a SBOS system. For American this thing, so they also developed a national differential global positioning system. When you say differential positioning global positioning system, it is a more of a localized area. It can be within 20 kilometers or 100 kilometer range, whereas NDGPS is for the whole country. So that means they establish network of points, a network of GPS locations, and then getting the positions, and again connected to the geostationary and improving the accuracy. It will give the accurate positioning at the national level. America has done for that. Another is Chinese BIDO system or compass. China also has established its own GPS. You say it is not GPS, but it is own GPS. But similarly, like IRNSS, it is for Indian region. Chinese BIDO system, this compass is for a China region. But they are also going expanding. So initially started with their own, but now they are expanding to other regions. Similar like SBOS, they have also continuous operating referencing stations. So it is basically established by NASA. Basically, you operate for getting high accuracy positions of the points, and then you communicate to the people. So those people, they can use this for improving their own positions. So it is can be used for scientific purposes, etc. And a global differential GPS, GDGPS. So this is also a network of locations where you continuously observe, and that observed values are used further improving the accuracy. So there even you can through internet, you can also submit your own positions using the global differential GPS. So they will be able to correct and provide the accurate position or improved position or enhanced position, augmented position. You get it using these systems. International GNSS service, IGS. So this is also there is a network called IGS where they have established centers, more than 100 locations where they continuously observe and real time monitor the plate tectonics and geodynamics. So for that purpose, these networks are being used. So everywhere, whatever is being done, it is done to improve the accuracy. Earlier, so what I say is, if you have a one type of system, so the one GPS instrument, you get accuracy, general absolute positioning. But if you wanted to have a higher accuracy, these type of SBOS systems and differential positioning systems are required. So as I mentioned earlier, continuously operating reference systems. It is managed by National NOAA, basically archives and distributes GPS data for precise positioning tied to National Spatial Referencing System. So these things are also used for developing a framework for the country. Like a Survey of India, they have their own framework where that grid network is used for developing the maps. Basically, higher accuracy of reference frame is established using these points. So this is one system used for a USA. Similarly, there is another thing is called one more course, India. It is also started last 2-3 years. So even IERS people, Astos Bharadwaj and other people are also involved establishment of this course network. Similar like this course operating system for USA, we have our own course system established at different places. So it is used for this one GPS, Gagan IRNS data analysis for plate dynamic profiling in active seismic zone. So it is used for basically for plate movements and like landslide predicting, etc. Now, as I mentioned, that global differential GPS is a highly accurate GPS augmentation system developed by NASA Jet Propulsion Laboratory to support the real-time positioning. We notice that real-time positioning you can get it, timing also you can get it, and then determine the determination requirement of NASA scientific missions. So this is one requirement. Another is IGS. It is a network of over 350 GPS monitoring stations from 200 contributing organizations, 80 countries. In support of earth science research, multidisciplinary is also used for a different purposes, as I mentioned earlier. Now coming back to this SBOS, which are established all over the world. So you have a VAS for the USA, and IGNO is there, European Global Navigation this system for Europe, and SDCM is for the Russia actually, Gagan is for India, and then MSAS and QZSS for for Japan. And these systems basically done at the national level or regional level, so that it will help them to improve the accuracy for the this basically cost on the user will basically will be reduced. How this principally how it is working is, at location of these ground stations, corrections are calculated for ionospheric errors. So because ionosphere, it also delays the signal. So that means it will also cause error for the positioning. Clock error means that GPS satellite which is there at the in the orbit. So if there is a small error of GPS, it will give the different accuracy. And ephemeris is what is the orbiting parameters of these satellites, whether it is in proper orbit or not, if it is up and down or some other all orbiting parameters of the satellites are called ephemeris. So these corrections are sent to the geostationary satellite, as I mentioned like earlier. So the signal whatever we receive from these ground stations, along with their own measured positional information, so that the difference is again automatically calculated, and then that is sent to geostationary satellites, who then provide a signal very similar to that GPS satellites and on the same frequency, so that GPS instrument they can receive this information. Therefore, these satellites may be used for position calculation and correction data sent out to improve the position calculation. So this is the principle on which it basically works. Coming back to the different SBOS systems, VAS is one SBOS systems. So it is basically FAA, that is Federal Aviation Administration. It under the Department of Transportation in USA. So they developed this system. Currently, GPS alone does not meet the navigation requirement for accuracy, integrity, availability. Actually, as GPS, as I mentioned earlier, if you talk about only GPS, if you don't use this network, your corrections are your accuracy is very less. Maybe 20 meter, 10 meter, 15 meter. It varies also. If you use these VAS-based systems, your accuracy can improve up to 3 meters. Then you can also ask, suppose how do I get the instruments which are VAS enabled. So that's why when you buy systems, you should also buy systems which are enabled to receive this as SBOS signals. For in India, you have that Gagan. So you can ask when you buy the systems whether it is SBOS and this one Gagan enabled means you can improve the accuracy. If it is not Gagan enabled means it will give the less accuracy. Only standalone made, how do you get in that? So this is a wide area augmentation system network. If you see this, these yellow points are the network of the points, wide area reference stations, and then these are all initially established, and these red points are further established later on. So this is a whole network of ground stations, and then there is also point on the left side and the point on the right side. There are antennas are there. So these ground stations, WRS points, they communicate the signal to these antennas, and these antennas are uplinked to the geostationary satellites. So that means your whatever is ground station measured value and collected value, both are sent here and communicated to geostationary satellite. From there it will be again downlinked, and wherever you are with VAS enabled GPS, you get your accurate positioning. Similarly, other systems are also there. So as I mentioned earlier, so this yellow colored is that GPS instruments, GPS satellites, and then these are all the boxes, rectangular boxes, whatever is given. So these are all called the reference stations. That means they are the points where highly accurate points after precise measurement, and then they are also having collecting information from the GPS, and this information again communicated back to master center, master station. From master to uplink station, the antenna, it will uplink to geostationary satellite. So these geostationary satellites again communicate back the signal wherever the user is there, either in aeroplane or on the ground. So they receive the information, and then the signal is corrected for accurate positional accuracy for that point. So this actually commissioned way back in 2003 and 4, and then parallelly they also developed local area augmentation systems. So it can be also implemented in our airports. Can be used even for flights landing and taking off from these locations. As I mentioned here, National Differential Global Positioning Systems. It is a network for the whole country, that is USA country, basically for improving the positional accuracy. Now, if you talk about that, this image shows, if you take a general accuracy position, it is coming around 35 meters range. So it is taken way back, but now the accuracies are improving. But that time it was 30 meters. Now even 20 meters we are getting. So this with the GPS values. But if you use this SBOS systems, your accuracy is tremendously improved. You see this? It has become yellowish and white color with the GPS plus IGNOS, European Global Navigation System. So there if you use combined together and your accuracy is coming earlier 30 meter, it is reducing a less than 5 meters. So that way you can improve your accuracy. So there's the same IGNOS like VAS for America. So these are also having its ground stations, and then again uplinking station antenna they communicate, and from there again they uplink to that and downlinked. So that your GPS IGNOS enabled instrument will receive that signal and then help to improve the accuracy for that European region. So this I think I discussed again, the slide has come here. So basically this basically correcting ionospheric errors, clock errors and then ephemeral errors and providing the better accuracy of that particular location. Similar to that, one is IGNOS, another is VAS. Similar to that, one is MSAS, is a Japanese SBOS which support DGPS, this thing by reporting then improving on the reliability and the accuracy of this thing. So it is commissioned in September 2007. It is able to correct its own position, offering a much greater accuracy. Typically GPS signal is improved from some 20 meters to approximately 1.5 to 2 meters in both horizontal and vertical dimension. Now QZ-SS is a quasi-Zenith satellite system, 3 satellite regional time transfer system. So if you see this, so the satellite's movement is like this. So because of this Japan area is covered and Australia area is covered. Using this you can improve accuracy for that region. This is another system which is similar to what I mentioned, like IGNOS and then VAS system, MSAS. So this is called SDCM. It is basically SDCM consists of remote stations, central processing facilities, uplink stations, terrestrial broadcasting, integrated use of GPS and GLONASS. You also have to understand, once you use a GPS, your positional accuracy may be 20 meters or 15 meters. Suppose if you combine together GPS and GLONASS, and the instrument itself will help you to improve the accuracy. If it is 15 meter, probably you may get 10 meter accuracy. So using more number of satellites, you will get a stabilized and more accurate positioning value. Basically here you are using a GPS and GLONASS. Most of the other cases what I mentioned is we are using only GPS. So why? Because this GPS, it is launched long back, and then having a full constellation of the satellite, and then no time, there is no reduction in the number of the satellites. If there's one satellite goes out of order, they have spare satellites, so that total 24 satellites are always available for getting the anytime anywhere positioning. But whereas GLONASS, when it is started, so once it has gone to even 4 or 5 satellites, that means they launched along with USA long back, but this GLONASS is launched by Russia, launched by USSR then, and then later on now Russia. So they launched, but later on that because of the economy, they could not maintain the minimum number of satellites. But again, now in the recent past, they launched many satellites. So now they are equipped with the total number of satellites desired. That means the 24 satellites and these 24 satellite GPS. So these satellites are available in the orbit. So the instrument makers who are doing, so they can also integrate receivers for both the GPS and GNSS, so that you get a more accurate positioning. So basically the instruments are GPS and GLONASS combined together. In addition to the GEO broadcast, this is like our INSAT system. It is foreseen that SDM provides a internet and GSM broadcast from SISnet server and then NT IP server. So that means through internet also you can improve the position. So these black color dots showing that the initial establishment of network of ground stations. So later on, all this orange color, that is the reference stations, further developed, improved, what do you say, network has been improved. The higher the network, the better the accuracy what we can get. Services are accuracy of 1 to 1.5 meter in the horizontal and 2 to 3 meter in vertical. In addition, it is also expected to offer centimeter level processing service for users at the range at a range of 200. You also have to understand another point. Suppose if you have a reference station like 16 here, if you go near to that and collect the information, your accuracy improves. But if you go further away from that, automatically accuracy also reduces. So the nearest is the point, the more accurate you become. The farthest, your accuracy also reduces. Even in DGPS, Astos might have mentioned parts per million. Accuracy, it is mentioned in parts per million. When you use a DGPS, that means 1 part in 1 million. So that means in 1 kilometer, your accuracy is 1 millimeter. That means within that network, within the station from the base station, if you go 1 kilometer, it is 1 millimeter. If you go 1 kilometer, 2 kilometer, it is 2 millimeter. So the away from the point, from the accurate station point, your accuracy also reduces. So that another thing you have to understand. So that's why if it is within 200 kilometers, your accuracy level is higher. If you go beyond 200 kilometers, then accuracy will also reduce. As I mentioned, Gagan, I am not talking in detail, but this is one slide. With collaboration with cooperation with USA, we established the Gagan, GPS-aided geo-augmentation navigation to improve air traffic and other civil navigation. Joint venture of ISRO and Airport of Authority of India is 770 crores. And further also they enhanced. Now I think from 8 stations to they improved to 12 stations. 17 stations. So it has now increased almost more than double reference stations. As I mentioned, if you have more better network, you will get a higher accuracy. Master control and uplink facility is also there. So I will not talk much on that. I think we will cover detail when that lecture is there. I think 21st. So by Karthik from Indian Space Research Organization, Satellite Application Center, ISAC. Another important thing is a local area augmentation system. It is called LEAS, ground-based augmentation system. There are two things. One is you have a GPS satellites. Another is you have a ground stations which are there on the ground. So these ground stations basically are used for improving the positions, And again, they are also receiving these ground stations, and then there are also nearby stations where also located, established. So those established stations basically communicate to the flights. Whatever the signal is received and corrected, the corrected signals are communicated to the taking off or landing satellites, so that the position can be improved very with very high precision. So that their accuracy is maybe within less than meter, so that it will also help in better landing and taking of the aeroplanes. So this is about, that is mentioning about local area augmentation system. It is all weather aircraft landing system based on the real-time differential correction of the GPS signal. Local reference receivers send the data in a central location at the airport. The data is used to formulate a correction message, which is then transmitted to user. Where user is a flights VHF signal. A receiver in the aircraft uses this information to correct GPS signal, which then provides the standard instrument landing system, that is style display, to use while flying in a precision approach. So these signals further used for landing and taking off. So that is main purpose of this. As I mentioned earlier, regional navigation systems. So that is a compass navigation system. It is from the basically from the China, independent global satellite navigation system, mainly for China. Constellation of 35 satellites, which include 5 geostationary and 30 medium earth stations. CDMA based signal. Compass M1 satellite launched in 2007. I think last year I corrected, but you can also check in the internet. So total satellites may be more now. So earlier it was 7, but I have to check how many satellites are there. You yourself also can check from the internet how many these compass navigation satellite. Compass or BIDO, all together this thing. They have their regional network as well as the global network. So these are used basically improving the accuracy of the position on the ground. Another important thing is, as I mentioned earlier, government versus private. So Starfire is a navigation system developed by John Dare Navcom and Precision Farming Groups. So it is basically entirely commercial and private. You see, what they are telling is to achieve accuracy of 4.5 centimeters over a 24-hour period. Suppose if you wanted to live and real, so this may not work. But if you wanted to work for the other applications where you require positional accuracy very high, for surveying and map making and other application, cadastral applications in urban areas. So where this 4.5 centimeters very high accuracy, so these type of systems can be used. Another is Starfix commercial service for offshore accurate positioning. So one is Starfire for this ground-based network. Another is Starfix for the who are going into the ocean. So internal ocean-based services. So these are all the commercial-based augmentation systems to give you the high accurate positioning. So with this, I covered related to satellite-based augmentation systems, ground-based augmentation systems, and regional and global satellite navigation systems. To summarize, GPS, GLONASS, Galileo, these are all global navigation satellite systems. And then you have regional navigation systems like IRNSSS, Indian Regional Navigation Satellite System for only India and surrounding countries. And then we have a BIDO and then COMPASS systems developed by China, used for the its own country as well as for the global. And then you also have the different survey techniques. As I mentioned earlier, basically these survey techniques are used basically to improve the accuracy of the position. So standalone positioning, relating positioning, and then you have a DGPS. So these are the different technique, different mode of techniques what to use for getting the different type of accuracies. So then coming to satellite-based augmentation systems. So these satellite-based augmentation systems are developed for USA through WAS, Wide Area Access Augmentation System. Another is IGNOS, European Augmentation Systems, and then MSAS for the Japan, and Gagan for the Indian region. So in addition to that, country level also based DGPS have also been developed. That is called ND GPS, and then global level accuracy position like IGIS, International Global GPS systems, and then you also have a chorus systems. So this is also used for plate tectonics and dynamics positioning, etc. So to summarize, these augmentation systems are very important, play a very important role, and also enhance the positioning applications with the increased accuracy. Your type of application requirement also increases. With that, I take this time to thank you all.